Hi again. Another important question is, sketch the curve stating the coordinates of the vertex and whether there is a maximum or minimum value of y for this function. So here we have a quadratic equation because the highest x power is 2. When we have a quadratic equation, we know that the shape of the curve can be a concave down or a concave up with only one single vertex. However, when you look at the leading coefficient, which is -4, is below 0. It's negative. Therefore, the shape of the curve should be a concave down curve. Therefore, in this case, you see that we have a maximum point. So the maximum value at the same time represents the vertex point or the vertex coordinate axis, which is defined by the x coordinate and the y coordinate of the vertex. Then how to find that vertex? We need to convert the quadratic into another form, which is called the vertex form. And the vertex form is achieved by completing the square method. As we said before, completing the square method is working like this. We first need to write down the function in descending order. That means it's -4x squared minus 2x plus 3. Then the leading coefficient must be 1, not -4. Therefore, we need to take out -4 as the common factor between the first two terms. So x squared will remain here. Then we have taken out -4. So it's like if we are making a -4 over -4 here, beside to -2, when we take out -4 to the outside, at the denominator -4 will be left. And -4 with -2 is like we have -2 over -4, then it becomes +1 over 2. So here that would be +1 over 2x, then close the square bracket, and plus 3. Okay, then the next step is to convert the two terms inside the square bracket to the completing the square form. Open a squared parenthesis, then take the square root of x squared, and then the coefficient of x divided by 2. The coefficient is half, and divided by 2, it becomes +1 over 4. At the outside, you need to subtract the square of 1 over 4. Then close the square bracket, and then we have plus 3. Now we do further simplification. So you can say it's -4 times x plus 1 over 4 all squared, then minus 1 squared is just 1, then 4 squared is 16, plus 3. And then we can open the square bracket, -4 times x plus 1 over 4 all squared, then -4 times -1 over 16, it becomes +4 over 16. Then you can do cancellation, and 1 over 4 will be left. Then plus 3. This is -4 times x plus 1 over 4 all squared. Then 1 over 4 plus 3, you can actually say the denominator for 3 is 1. Then you need to find the common denominator between them. The common denominator between these two terms is 4. So you should say it's positive common denominator, which is 4. Then it's like for this second term, we are multiplying it by 4 over 4 in order to make the common denominator. This is the common denominator. Then 4 times 3 is 12. Plus 1, it becomes 13. Therefore, here we just write 13. Now you see that this form of the quadratic equation is the same as the vertex form. So by comparison, you can say that by comparison, it's the same as you say a times x minus h all squared then plus k. The value of h represents the x-coordinate of the vertex, and k represents its y-coordinate. Therefore, when we want to state the coordinate of the vertex, we need to write down, therefore, the vertex coordinate is, its x-coordinate is the value of h. So you see that in the formula we have negative h, but here is positive 1 over 4. Therefore, h coordinate is negative 1 over 4. And the y coordinate is represented by k. So k is 13 over 4. Therefore, this pair point of xy represents the vertex coordinate, which is negative 1 over 4 and 13 over 4. Okay, therefore, the vertex coordinates are, you can say, its x-coordinate is, look at h. H represents the x-coordinate of the vertex. In the formula, we are using negative h. Here is positive 1 over 4. Therefore, h represents negative 1 over 4. Negative 1 over 4. And k is the y-coordinate. So k is 13 over 4. Therefore, this represents the vertex point. And then at the end, we need to give the maximum or minimum value for y, for the function. As long as the function was a concave down, the curve of the function was concave down curve, therefore you can say that, therefore, there is a maximum value of y